This is from JAM 2022 mathematics paper. So this question number 17 says that for xy belongs to this matrix 2 by 2 matrix, define xy x comma y as xy minus yx, and let 0 also belong to this square matrix 2 by 2, denote the 0 matrix. So we have two statements p and q over here, and we have to find which one of the following is correct, whether this p and q are true or it is true or false. So we will check with that. So for the question to solve, we will start with this p and we will try to write this p. So the p has this form x comma yz, so we can write it in this form, the whole expression, and also the inside bracket, this the yz zx, we can this the total expression can be decomposed into this particular equation. So just let's write this in this way. So p equal to x of yz minus zy minus yz minus zyx, okay, plus of y zx minus xz minus zx minus xz of y plus z of xy minus yx to be yx minus xy minus of yx into z. So from here we can write the whole equation in this way, this multiplication xyz minus xzy minus yzx minus zyx, it will be plus yzx minus yxz minus zxy plus xzy plus of zxy minus of zyx minus xyz plus of yxz, and you will see every term will cancel each other and it will be 0. So in our case p is 0. Okay, so p is coming as 0. Now we will check with the q. So q is given. So in case of q, we will first on the left hand side x yz minus zy x, sorry, it will be minus yz minus zy into x. So we can write it in this way also, this xyz minus xzy minus yzx plus zyx. Okay, we can also write it, this is the left hand side. So now on the right hand part, so we have this xyz, so we can write it in this way, xy minus yx into z minus of z into xy minus yx. So we can write it in this form also. This xyz minus yxz minus zxy plus zyx. Okay, so now if it is, so this to be equal, this must be equal, these two terms, okay, is in the right hand side and the left hand side, so they must be equal for q to be true. Okay, so if suppose let us consider this, let us assume that these two are equal. So even if these two are equal, we will find that, so after cancelling all the terms, we will have this equation left, yxz plus of zxy, which is not equal, right? So in our case, q is not true. Okay, so q is not equal to this particular function. So for this question, the correct answer is p is true but q is false. Option B is the correct answer. So question number 18 is saying that consider the system of linear equations. We have these four equations with four variables x, y, z and t, and where this lambda is a constant, then we have to find which one of the following is true out of these four options. Okay, so first we can write it as the augmented form. So how to write that? So it will be, okay, so we can write it in this form. So this is B and the augmented form. One, 1, 0, 1, 2, 0, 0, 4, minus 4. Third row will be 1, 1, 1, 0. Fourth row will be 1, minus 3, minus 1, minus 10. And we can write it as this 4, 7, 5 and lambda. So these are augmented matrix. Okay, so now we will do the row reduction of the Gaussian elimination. Of the row reduction, we will perform some row operation to reduce this matrix into row reduced echelon form. So what we will do in this first hand, so keep the first row as it is. So it is 1, 1, 0, 1 and 4 is there. Okay, now in row 2 we will do this. So let's make it in another ink. So in the row 2 we will do operation. So R2 dash will be R2 minus 2R1. So what will be the elements over here? 0, 2, 0, minus 2, 0, minus 6 and minus 1. Okay, now we will do the operation on R3. So R3 prime will be R3 minus R1 simply. So we will put over here. So what it will be? 0, 0, 1, minus 1 and 1. Okay, and in the row 4, so in the row 4 if we do this, so row 4 will be R4 minus of R1 minus of 2 R2 prime plus of R3. Okay, so what it will be this after this operation? So all the rows it will be here 0 minus lambda minus 1. Okay, now we have two situations. So one is the lambda is not equal to 1 and lambda is equal to 1. Now coming to the part of the any, so now we find the row of this the rank of this coefficient matrix. First we find the rank of the augmented matrix. Okay, so it is in under the condition lambda not equal to 1. Okay, so lambda not equal to 1, so the rank of this augmented matrix will be 4 and the rank of the coefficient matrix will be 3. Okay, since the rank of the matrix augmented matrix is not equal to the rank of the coefficient matrix, so we know that according to this system of linear equation it has no solutions, right? No solutions. Now if lambda is equal to 1, we'll see that rank of this augmented matrix is equal to the rank of the coefficient matrix, right? So when the rank of the coefficient matrix is equal to the rank of the augmented matrix, so the equation has at least one solution. Okay, from the system of linear equation you know. Now see that the bottom row has all zeros in this particular matrix when lambda is equal to 1. So in that case it will be infinitely many solutions. When all the rows, the bottom rows has all zeros in it, so we can write it as this as infinitely many solutions. And in this case it will be for lambda equal to 1. So in for this question, so the option is correct option will be C. So if lambda is equal to 1, then the system has infinitely many solutions.